2.5 answers. 2.5 answers. Make sure they match up. Make sure you have any questions. These really, guys, if you know how to work a calculator, you know how to work your Desmos, these should almost be give-me's. Let me say not all of them, because you do have to rewrite them, which is not, that's probably the hardest part about all this stuff. But anyway, number A, or letter A, 583, bless you. 2 times. 580, 3 times. 4. Done? 4, nice. Is that typical?
Yeah, usually it's at least 3.
I'm always 2. Yeah. Okay, anyway. A, 583.8, I'm sorry, 185. And then B was 0.936. Any questions about those two? Y'all good? You'll be able to punch those up and find those numbers. That should not be any different from anybody. Those 3 decimal places should be exactly the same. If they're not, my guess is you plugged the number in incorrectly. Okay? Please be very careful of that on a test, because if you plug something in incorrectly, then you get wrong answers. However, if you plug it in incorrectly, then of course you're going to get this one wrong. But you won't. You will get it correct. They don't double ding you. So if you get it wrong in the equation, or your calculator dies, or you don't even know how to do it, make up an equation and plug in the number, and they'll give you the points for plugging it in. That kind of makes sense what I'm saying, okay? They don't double ding you. If you miss this, you're going to miss this. But if you miss this and do this correctly, they'll give you the points for this, okay? It should take about 120,303 children. 120,303. That is a comma. It's not a decimal. Okay? 120, because it was in thousands. It was in thousands. Under 5 years old are predicted to die. So you should always answer those somewhat in context. Don't just leave it as just a blank answer. It should always be, you know, you're probably okay with just children, but because that's what they asked. Approximately how many children under 5 years old are predicted to die? So when you get your answers, you just answer that. Children under 5 years old are predicted to die. That's kind of morbid. All right, number 2. A was 31.6016. So if you left out a 1, that's fine. If you want to change it to a 2, that's fine. If you want to take it out to the 6, that's fine. B is 0.9281. Okay, make sure they're stored in your calculator. Make sure you know those. There's the calculator steps. I'll post the answers to this also. Based on the model, how many visitors? So it should be 7.1189 million. And you can put it in words. You don't have to put, 7,1108. You can do 7.1189 million daily visitors after 20 months. And then letter C, point. So this is the one, is that the one? Yeah, that's one it takes you got to know math to know that one. So 0.4089 is what the value of T. Find the values, find the values of A and B. I'm sorry. I don't know where A and B are. Find the values of A and B. B1, B2, yada, da, 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 da. I don't see the answer on that one. I need to probably do this myself instead of use theirs. A, 4,670,683.6405 people. I know it's people. Still take it out 3 decimal places. Still take it out 3 decimal places because you're estimating. You're estimating. So because, and that'll kind of be talked about today. Hit me.
On the last one, I got a
Yeah, hit me. Where did you get?
I got 26.46.
My guess is because you have B to the what? What is b to the? B to the what? Just straight b to the x?
A is constant.
Yeah, but I'm. I know. We'll chit chat. Here, this is not to this question, right? Oh, I gotta have a pencil. Where's it at? Here, this thing. Show it. I didn't have to log in like 15 times. Y'all okay with that? Whatever, just blanket effect. A's not 4. A's not 4. Because they want you to say, they want to use y is equal b to the x. And that's not b to the x. That's b to the x minus 3. Okay with that? So they want you to write it where x is just the exponent. And so this is where we have to use what we learned in 2-4, where you have the 4, and now I can rewrite this as 2 to the x times 2 to the negative 3, right? Because you can subtract, if that's subtracting, then you can multiply, because if you multiply, you add the exponents. And then 2 to the negative 3 is 1 over 8. And if it's 1 over 8, that 1 over 8 can multiply to the 4 because it's just a constant. And so 1 over 8 to the 4th makes that actually 1/2 2 to the x. And so A is actually 1/2 and B is 2. Yes, no, okay with that? So now I don't know if that happened on the last question or not. Bless you. 3? Is that typical? Okay. Statistical minds want to know what the average number of sneezes is. Not statistical minds. I do. Y'all follow that? So just because you get A is 4, don't tell me A is 4 if they tell you that this is, assume that the equation looks like A times B to the x. Okay? You have to rewrite B to the x because this is not B to the x. That's B to the x minus 3. And so you need to write that as 2 to the x times 2 to the negative 3 because 2 to the negative 3 is just a constant. And that constant multiplies with the 8 to get the constant. Or I heard somebody say it earlier, the initial value. Because if x is 0, then that's b to the 0, which is 1, and 1 times that is the initial value. That's where it's starting at. Okay? Because at 0, that's my initial, that's my starting value. That's how many I'm starting with. Okay? Yo, good? That's the hard part about these. That's where your calculator doesn't give you that information. You got to find that because your calculator, let me rephrase that. Your calculator does do that because it just finds A and B because it raises B to the x. So that one probably was wrong, I'm guessing, because you had to use a calculator to find that?
Yeah, something went wrong.
Oh, something went wrong. It's okay. It happens. Get comfortable with these calculators. We're going to do some more stuff with these calculators today. You got to get comfortable with them. You got to know them forward, backwards, ups, downs. You got to get comfortable with them. Okay. Okay. 3, that was that 4 million number. B, we had let represents the number of seconds. B, I don't know. They got 1.0011. C, what is the appropriate domain? They didn't even put the answer for that one. Oh, there it is. So the domain was in minutes. Because it was in minutes, it went from 0 to 180. Because I'm changing it to seconds, it will now go from 0 to 10,800. You multiplied it by 60. Okay. 4. A was 3.3213. B was 1.78405. And then what is the value of f to the 5? It should be 60.0268. He puts the ... You don't have to put the ... Was that it? No. I don't know what happened to all this stuff. What is the expression for S sub t? Let's see, they put 100, 1.3104 x divided by 7 because this was all in weeks, I'm guessing. Yes, that was 31.4% per week. That's assuming you know how to do the 31.4%, the 1.314. We had to turn it into days. That's why they do that, so that you can't use your calculator to convert it. Because then I'm going to guess they ask for how many days. Oh, no, that's a solving. So 365.5444 days, or almost a year. 1876, 1876.1851 bacteria. 7, write the equation. 39645.83 was A and B. And let me find M, find K. I don't know, 0.9845. I can't really follow what the heck he's doing there. Was that it? Nope, nope. Number 8, 9.1. Use the given equation. Use the given data to write two equations. So A to the B is equal to 3.4, and A to the B to the 7 equals 9.1. This is a free response question on the AP test. I mean, that's one of the questions. I told you we know the questions. That's one of the questions, or at least it was last year, or 2 years ago. And then you had to find A and B, and of course you can find that with your calculator. He tried to do it manually. Please don't do it manually. Use your calculator. What was this? Selected the functions for each, find the constant value that can be, oh, this was the one where I had to, that's the mental one too. Okay. I think they do it differently than I do it. I still like the algebraic way of 2 equations, 2 unknowns. I think they do a lot of guess and check. So this one was -1, this one was +2, and this one was -1. Is that all you had to do is find that, right? Oh, then write the equation. Okay. Gosh, I know it's been like a week ago. What do I need to show you guys so that you know how to do it? Hit me.
Some of the answers vary slightly depending on how many decimals you use. Like they use 4 decimals a lot, and that won't matter on the test.
As long as you do 3. As long as your 3 match their 3. They shouldn't be off any. They shouldn't be off any. But if you don't do 3, it's off. Right? You got to do 3. You got to do 3. Great question. What else questions? Anything I need to work, show? Anything. Take. I hope these are easy questions. I don't want you to miss an easy question. Get comfortable with your calculators. Get comfortable, please. We'll do some more today with them. Anything I need to show? Anything. Speak up forever now. Hold your peace. Everybody good? Everybody good? Seriously? Send me an email or sign up for Flex if you need it. If you're too scared to ask. Yes. Yes. Paula, I think it's your time too, huh? Okay, here we go. 2.6. 2.6. 2.6. You snuck in on me. Ryan, you snuck in. Don't let me leave you without counting y'all present. Who else snuck in? I think I fixed you. All right, 2.6, 2.6. Again, it's going to be more calculator stuff. Just kind of get your breath. 2.7 on Wednesday, 2.8 on Friday. Review, test, I think, according to the calendar. Look at the calendar, but we got a test coming up. We're going from 2.1 to 2.8 as a test. Throughout this course, we'll have many opportunities to work and create models using given data. There are particularly important examples of this: linear, quadratic, exponentials. And we've talked a little bit about that already. We have a model that looks linear, or a model, so it's a word problem that might look quadratic, and we have one that looks linear. Linear and quadratic look similar, just sorry, I keep saying linear. They don't look similar at all. Quadratic and exponential look the same, just the quadratics don't go up near as fast as an exponential. So here we go. On the AP exam, students will be expected to determine which model is most appropriate giving a data set. There are a few strategies and methods that we can use to determine whether it's linear, quadratic, or exponential. Okay, so this part, goodness gracious, I hope you know this by now. If you don't, we're in the wrong class, right? Linear. Now, guys, when they're talking about this, it's not going to go perfect. Okay, it's not going to go perfect. So, for instance, this point right here, and this point, and this point, and this point, they're a little off, but it looks somewhat linear overall. So they're talking about the overall pattern. Okay, and they might do it. That what they're saying is, you could do it by a graph. You might see it by a table, or use them. Pretty much that's it. I sometimes take the table to the graph because sometimes that helps me see it. Of course, a quadratic will typically start high, go low, and go high, or might start low, go high, and then go low. So that's what makes it quadratic more than a exponential, because exponentials don't high, low, high. And I say that, they can have a little bit. And then this is an exponential, where you can just see it getting bigger and bigger and bigger and bigger. Again, you won't see a constant difference over here. So if you try to find these differences, you may or may not see a constant difference, or a constant multiplication, proportional. I have a tough time with that word. Okay, here we go. Example number 1. Selected values from several functions are in the table below. Sketch the scatter plot for each table, then determine if it's linear, quadratic, or exponential. So luckily, those are the only 3 choices we have: linear, quadratic, exponential. Plot those. Are there 4 of those examples? 1, 2, 3, 4. Plot those 4 real quick. Plot those 4 real quick. And you tell me if you think it's exponential, linear, quadratic. Oops, I'm an idiot. Y'all good with the first one? Thinks it what? Don't connect these points. Don't connect them. Just plot the points. Because you don't know officially what's happening between them. So don't connect them. You're just trying to decide on if the data is linear or not. Okay? So I believe that one is definitely a line R. -1, 2, 1.5, 5.5, 4, 10.5, whew. Oh, 6.5, 5.75, 9, 2.5. Goodness gracious. I could guess absolute value maybe, but that's not a choice. So that one's quadratic. I know. I don't care. Which one's the T? Quadratic. Here? They don't count off for spelling, luckily. 110. 3, 5.2. 5, 2.4. 7, 1.3. 9.7. Exponential. -2, 2, 1, 3, 4, 4.5, 7, 6.75, 8, I'm sorry, 10, 10.2. Woo, that's close. Can we all agree it's, which one do you want to go with? It's going up in a curved pattern, or is it going straight up? Curved, exponential. I agree. I agree. If that one was a little bit lower, the last one, if that was a little bit lower, I probably could argue linear. I did? What I did? Oh, 10. That's way over here. What? Gosh dang it. Cuss. This dyslexia thing is bad. I do, but that's okay. I normally cope with it fairly well. 7, 6.75. 10, 10.25. That even looks more linear. I'm still going exponential. Still going exponential because I think it's curving. As we progress throughout today's lesson, this will not be a discussion after rest of today's lesson. That is definitely exponential. Okay, no, I don't want to do it. Homework, I don't care if you abbreviate. Test, I don't think I would abbreviate because you got the words up there above you. You know how to spell them, do everything else. More than likely, that's a multiple choice type question. Okay, here we go. We're going to talk for a little bit. Residuals. This is new to you. I know, there's no doubt about this. Residuals. Well, it's new to everybody but Paula. She's not here. When we create a model, we can use our model to predict values for that dependent variable. So this stuff is this kind of like big picture. This is what we're doing, right? You have independent variables and dependent variables. Your input variables are your independent variables are your input. Your dependents are your outputs. These are your X's. These are your Y's. I'm getting close, aren't I? Got it. When using a model, it's important to remember this is only a predicted value. You are predicting what the value of Y is. It is not the exact value of Y. Your exact value of Y comes from the table. Those are the exact values of Y. If I come up here and I'm predicting, so I find this line of fit, if you want to call it that, or like what we did for our homework, right? It's not going to hit those points exactly. It may not even hit a single point. It tries to get as close to those points as possible, but it may or may not hit any point at all. And it might hit one or two. I don't think it's going to hit all of them unless if it goes perfect. Okay? So we're predicting a model. Okay? If we use the input value for a known data point to find a predicted output using a model, the difference between the output and our predicted and the actual output, let me rephrase that, I'm sorry. Between the actual output and our predicted output is called a residual. What class are we in right now? Pre-cal, what's in front of it? AP, don't forget that. It's the actual minus the predicted. Don't do predicted minus actual, because if you do, you're going to get it wrong. Okay, that's what the residual is called. Residual. It's the actual minus the predicted. The actual point is what the actual point is. I mean, that is the point. The predicted point we're getting from our equation. It is probably not right on that point. If it is, then that residual is 0. Sometimes we have positive residuals and sometimes we have negative residuals. A positive residual is above the actual point. A negative residual is below the predicted point. Okay, with those two things. And that's why you have to subtract it correctly to give you negative and positive residuals. Okay, you have to know if it's negative or positive. And if you don't subtract it correctly, and it's okay, sometimes you may not, you still just need to think about it. Am I below or above the line? And if I'm below it, then I should be a negative residual. And if I'm above it, I should be a positive residual. Okay, very good. Okay, residual. You got to know what that word means, and you got to know what it is. All right, here we go. Example number 2. The weight of newborn babies can be modeled by a linear function. Guys, you got to read. We got to read in this class. I don't have to guess if that's linear, quadratic, or exponential. They told me it's linear. That's what I'm going to go with. For the first 4 months after birth, selected values for the weight in kilograms of a particular newborn baby are given in the table above, where T represents the number of months since birth. This is the number of months since birth. This is the weight of the baby, and it's in kilograms. You need to recognize all these things of what it's in and what it's going to. Use the regression capabilities on your calculator to find a linear model in the form of y equals a plus bx. That's really important. They don't want mx plus b or ax plus b like you guys are used to doing. They want the a plus bx for the weight in kilograms of this particular baby months after birth. So you're going to go to your little calculator, or you're going to go to Desmos. I don't care whichever one you're more comfortable with. You really should be comfortable with both. I'm just, again, just kind of prepping you a little bit for the test. If you open up Desmos on your calculator, it takes up 90% of your screen, maybe 80% of your screen. It covers up a lot of stuff. And so you're continually having to go back and forth between the numbers and trying to remember what a number is, and just kind of picture that as you're taking this test. Okay? You can have a calculator and you can have Desmos and you can have scratch paper. But there's just kind of understand all that stuff. However you want to work it, I don't care. If you have your calculator right there, you can go from number to calculator. Okay? Stat edit. We got to put that data in our calculator. I always use L1 and L2, and I use L1 as X's and I use L2 as Y's. And if you have stuff in there, hit second plus and clear all your lists. Clear them all, because you don't need anything else from previous. Right? Boom, clear all. Number 4. Good, done. Right? And remember, if you don't see L1, 2, 3, 4, 5, or 6, do stat setup editor. And if you want to, you can do it anyway, just to make yourself feel good. Stat edit. All right, here we go. Y'all gonna help me out. What are the X values? 0. 1. 2. Nice. Oh, that was easy. I probably could remember that for Desmos. 3.2. Uh-oh.
5.1. 5.8. 6.4.
No reason to make all that noise. Beautiful. Everybody happy, happy, joy, joy, right? Remember, that's there forever. You can still use your calculator. You can do whatever you want to it, but you still haven't found the equation. So we got to go stat, and we got to calculate. And we want a linreg. And I don't really want number 4 because that's ax plus b. I want not quadratic. I don't want cubic. I want quartic. I want linreg a plus bx. And they tell you which one to choose. So go ahead and use it. Hit number 8. Boom. L. I always put it in my Y1. Whether you need to or not, alpha, trace, Y1. I always store my equations in Y1. I don't know if I'll need it or not, but if you need it, if you need it and you don't do it, you have to go back and do everything. You don't have to put it all in, but you're looking to save time. Calculate. There's your A, there's your B. Wow, those aren't very big numbers. So A is 3.34 and B is 0.8. Beautiful. So there's my equation, except I'm not going to write it y equals that. I'm going to write it as what they want me to. W T equals A was 3.3? 3.34? 3.34 plus 0.8, and I'm not going to put X, I'm going to put T. And Kron, a couple of you guys have asked, like, there's no work to be shown for this. I mean, everybody in the world who's grading this test know you use your calculator to find that. I used my calculator. Okay, good. You don't have to tell me that. We know you did. There's nobody in this world can come up with that without using a calculator or doing a crap ton of math, because you can do it manually, but you don't want to. Use the model found to predict the weight that's 2.5 months. That's why I put it in Y1, because it's already in Y1. So now you can clear if you want to. Now I need Y1. That's like F of, what was it, 2.4? 2.5. 2.5. That's plugging in 2.5 for X. And so that weight is going to be 5.34. Make sure you put kilograms. I don't know if they will take off or not, but if you don't put it, they might. If you do put it, they won't. So I don't want mites. So Now this one I would probably do this. I would probably do 3.34 plus 0.8 and then do what, 2.5. Okay? And the reason why I would do that, guys, is if you miss this, if you miss it because you put in something wrong, that's the only way you're going to miss it, right? Put in something wrong in your calculator. That's the only way you're going to miss that. If you miss it and you don't show that down here, we're not too sure how you got it. So if you show this and show that and you got this wrong, then you're going to get the point here. Okay? What was it? I'm sorry, I already forgot my answer. 5? Was it only those two? It's messed up 3. I was trying to write a 2. Fixed it though. Beautiful? Beautiful. The actual weight of this baby is 2.5. Oh, I'm sorry. Of the baby 2.5 is 5.5. So did I over or under predict it? I under predicted it. What is the residual for this weight? Did I overestimate or sorry, I said it backwards. Gosh. Underestimate or overestimate? Well, we already know that answer. You can know that just by looking at the map. I mean, just by figuring that out. What we said we underpredicted it, right? Uh-oh, I need a pencil to do that. So I underestimated the weight of this, but now they want the residual. And you guys are brilliant enough now. You know that the residual is equal to the actual minus the predicted, and the actual weight was 5.5. And the predicted is 5.34. And so the residual is negative, where are we at? 0.16. Is that my math? I try to get out of the habit of circling answers. It's positive? Oh, because the bigger numbers. Duh. Watch this. Dude, uh-oh. There we go. Fix that. Do I have to have the pause on? No. Why do I have it? Because I want to erase. And make sure you answered that, right? On your test, you won't be able to circle. I don't rephrase that. On our test, you can circle it, but on the AP test, you can't because it's on a computer. So you're going to have to write it. So always make sure you answer the question. What is the residual for this weight? And you probably don't want a naked answer from that. Show them how you got it. Because if you mess up somehow in your math, they'll probably still give you a point or two because you know what you're doing. You just messed up a number. Did our model or underestimate? And because it's positive, we underestimated. Under. Okay? All right. Residual, you got to know that. Actual minus predicted. AP. Don't forget. Don't forget. This is all of chapter 3 in AP Stats. Not that you care. Okay, now let's look at this. A residual plot. A residual plot. We're going to use a residual plot to check the appropriateness of a model In other words, we're going to use it to check to see if it's linear, quadratic, or exponential. A residual plot shows all of the residuals for a set of data. It can be used to help determine if a model is appropriate for a given set of data. If a model is appropriate, the residual plot should appear, erase that and put scattered. I like that word better. If a model is appropriate, the residual plot should appear scattered. If we can see a clear pattern, and I don't really say a clear pattern because you guys, I mean, y'all are mathematical people. I'm going to guess you're up in a high math class. You can see a pattern pretty easily. There's only going to be 4 or 5 points. You can see a pattern. I don't want to see a curved pattern. I don't want to see a curved pattern. Again, you guys get bonus points because this is like my niche right here. In a residual plot, then the model was not appropriate. So we want the residual plot to be scattered. We do not want to see a curved pattern. Okay? We don't want to see a curved pattern. All right, we're good there. Residual plot. So let's look at it. This is a residual plot. And how do I know that? Well, because it says residuals. And notice that it goes all the way up to 3 to -3. It's also interesting to note that you're -3 and 3. Notice that 0 is right in the middle. 0 should be right in the middle because if 0 is not in the middle, you don't have a very good line, right? Because if you have a line of best fit, you should have some points above the line and some points below the line. If they're all below the line, you don't have a very good pattern. You don't have a good line at all. So that 0 should always be right in the middle. Notice that this one does look somewhat scattered. So that is a good residual plot. If that's a good residual plot, then the original set of data, listen to what I'm going to say, the original set of data was good, was appropriate. This is the x values. So it's the same x values. So now look at what they say. An exponential regression was used to model the data. The residual plot for the exponential regression model is shown. Which of the following is the best conclusion about the appropriateness of an exponential regression model based on the corresponding residual plot? So you guys are going to look at that residual plot and you're going to say, hey, it's scattered. So because it's scattered, what can we conclude about the exponential model? Good. It's Daijobu. Good. It's Japanese. The exponential was not appropriate. No, it was. Oh, I need a pencil. Let's do red. 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 It was 2. The exponential is not. Nope. It was 2. The exponential model is appropriate because the residuals show no pattern. I like that. The exponential model is appropriate because the residuals show a pattern. No, they don't. They're scattered. Soak all that in. I'll know that's all that's new to you. It's not that difficult if you know it. If you don't know it, that's freaking difficult because you just have to guess. Good enough? You want the residuals to be scattered. You want them to be scattered. All right, here they go. Is this the last? No, I got 2. Here's example number 4. Is that a good regression model? No. No, it's not a good one because I have a curved pattern. What about the second one? I don't think so. I got 2 curves going on there. Now, that one's better than this one. That one's better than this one. So if I don't have the third one, I would choose the second one. But I got the third one that looks better than the other 2. Okay with all that? Not only that, notice what this one goes up to, 15 and -15. This one goes up to 6 and -6. So those points are closer to the line because the residuals are smaller. And what about the last one? -0.3 and 0.3. Those points are really close to the line. So that one by far is a whole lot better model than the other 2 because the points are really close to the line. And not only are they really close to the line, they're somewhat scattered. A group of AP pre-calculus students used a set of data to create a linear, and you can see this says linear, this says quadratic, and this one says exponential. To create a linear, quadratic, and exponential regression models. After creating 3 models, the students created a residual plot for the types of models, see above. Based on the 3 residual plots above, which model is most appropriate for the data? Give a reason. Pretty much it's the definition of residuals. Model 3 is the best, or the exponential model is the best, because it is the most scattered. And if you want to add to that, not only is it the most scattered, it has the smallest residuals. That would like really help you. But that's not, the small residuals doesn't really matter. If these are smaller residuals and it still has a pattern, it's still not good. The pattern's most important. So, exponential is the best. It is more scattered than the other 2, or the linear and quadratic models. It also has the smallest residuals. They probably won't grade that, but man, if you can say that, woo, that really says I know what the heck I'm doing. Talk to me. If it's more scattered, it's more appropriate. That is correct. I see what you're doing there. You're putting the more and more together, huh? God, I love teaching smart people. Mr. Passwater hopes to make it to the Guinness Book of World Records by painting the world's biggest mural on the sides of several downtown buildings. His mural will consist of many painted circles of various sizes, where each circle is painted in a different color. He wants to create a model, determine how much paint is needed in quarts for a circle of radius R. Should Mr. Passwater use a linear, quadratic, or exponential? And explain your reasoning. Anybody got a guess? Why? It's area. What's area in? Squared. R squared, right? So we should use quadratic because you have R squared. I don't think you'd have anything else other than maybe squared, but they're looking at the quadratic part of it because it's area. Because area is in, what are we in? Quarts, radius, feet. Feet squared. We will use quadratic. Area. Beautiful. Question about that? You'll see some in your homework that won't be area, but you should be able to figure out if it's exponential or if it's linear or if it's quadratic based on that. After creating this model, well, that's the end of it, Mr. Passwater uses to purchase different special paint colors on his mural. In this situation, do you think it's more appropriate for the model to underestimate or overestimate the actual? This is like common sense, I would think, right? Like me, I don't want to go to Lowe's 3 times like I did yesterday. I went 3 times. Got the wrong part the first time. Second time, I didn't get enough parts. And then the third time, I got the right part. Actually, I really got the wrong one the third time too, but I wasn't going back. So I made it work. We should overestimate this because we don't want to go back and buy more. Yippee, yippee, yo. Yes, no, maybe. Easy peasy, lemon squeezy. Let me write that. Over. Because he doesn't want to go back to the store. 28 of you cats in there, there's probably 28 different reasons why, but just make it feasible. Yippee, yippee, yo.